Hello friends, so here is another question. So on superposition principle, multiple charges. So the question is that an infinite number of charges, each having equal value of 4 microcoulombs, are placed along the x-axis at distances of x equals to 1 meter, x equals to 2 meter, x equals to 4 meter, x equals to 8 meter, and so on from the origin. Find the total force acting on a charge of 1 coulomb placed at the origin. So this is the information given. We have to draw the diagram. Let us say we take the origin here. This is the x-axis. Okay. This is x equals to 0. Okay. One charge is placed at x equals to 1. Another charge is placed at x equals to 2 meter. Then another charge is placed at x equals to 4 meter. Another charge is placed at x equals to 8 meter, and it goes on and on and on like that. Okay, all these charges, let's say we assign them a common value q, where q is equal to 4 microcoulomb, and let's say we have a charge which is equal to q0, 1 coulomb placed at the origin. Okay, so what will be the total force acting on this q0 equals to 1 coulomb? So it will be application of Coulomb's law. So it will be the total force acting on q0 is equal to 1 by 4 pi epsilon 0 q0 q by this distance, which is equal to 1 square plus 1 by 4 pi epsilon 0 q0 q by 2 square plus 1 by 4 pi epsilon 0 q0 q by 4 square plus 1 by 4 pi epsilon 0 q0 q by 8 square, so on like that. So out of this we can take common q0 q by 4 pi epsilon 0. This we can take common. Then it will be 1 by 1 square, which is 1, 1 by 2 square, which is equal to 4, 1 by 4 square, which is equal to 16, plus 1 by 8 square, which is equal to 64, and so on. Okay. So if we try to find a pattern here in this series, whether it is in AP or GP, we'll see that the following sequence, this series, it is in geometric progression, where it is 1 plus 1 into 1 by 4 to the power 1 plus 1 to 1 by 4 square plus 1 into 1 by 4 to the power 3, and so on. Okay, so GP, where it is given by A, AR, AR square, then up to ARN. Here the sum of GP, the sum of the terms in GP, that is equal to A by 1 minus R. Here A is equal to 1, R is equal to 1 by 4. Sum of these terms, this total up to infinity, that will be equal to 1 by 1 minus 1 by 4, which is equal to 1 by 3 by 4, that will be equal to 4 by 3. So we'll simply substitute this value, that will be equal to the net force acting on charge Q0 is equal to Q0 Q by 4 pi epsilon 0 into how much? 4 by 3. The sum is 4 by 3. That will be equal to, we'll substitute the values. 1 by 4 pi epsilon 0 is 9 into 10 to the power 9. Q0 is equal to 1 coulomb. Q is equal to 4 into 10 to the power minus 6 coulomb, 4 microcoulomb into 4 by 3. So if we calculate it, it is coming around 4.8 into 10 to the power 4 Newton. The net force acting on charge Q0 placed at the origin because of the series of charges that are placed at distance which follows a geometric progression. Okay, this. Okay, so simple question it was, application of Coulomb's law, some basic understanding of high school mathematics, and we solved this question. Okay. Hello friends, so here we are with another question on superposition principle, multiple electrical charges, the net force, resultant force. So the question is that 4 equal point charges, each of value 16 microcoulomb, are placed on the 4 corners of a square of side 0.2 meter. Calculate the net force on any one of the charges which are placed at any corner you pick. You have to find the net force. So first step, to draw the diagram accurately as per the information. So we have to draw a square of side 0.2 meter. Okay, these are the 4 corners. Okay, these are the 4 corners. Let's name them A, B, C, D. Each of these 4 corners, they have charges equal to same charges, 16 microcoulomb, 16 microcoulomb, here also 16 microcoulomb, here 16 microcoulomb. We have to find the net force acting on any one of the corners. So let's say we pick corner D. Another important thing, the distance is the side of the square, it has a length of 0.2 meter. So let's say we pick this corner D, 16 microcoulomb charge placed at D. The net force, because of all the other charges A, B, and C placed at A, B and C, we have to find the resultant. So here 3 forces will be acting on D. First, because of the interaction of D with A, they are all equal charges, same sign, so it will be repelling type force. This force, it will be acting in this direction, in the horizontal direction, in the positive x-axis. Okay, so let's call it FA. Okay, another force will be acting because of the interaction between D and C. They are also same sign, equal magnitude, equal value, so it will act in the vertically upward direction. This, let's call it FC vector. Okay, FC. Another force will be acting because of the interaction between B and D. Okay, it will be in this direction, like this. F that will be equal to FB vector. Okay, so here this length of the diagonal will come into play. This length will be simple application of Pythagoras theorem, be 0.2 square plus 0.2 square root over, that is equal to this length BD. It will come into play. Okay, so first let us determine each of these values, okay, by application of Coulomb's law. FA is 1 by 4 pi epsilon 0 QA QD by RAD whole square equal to 9 into 10 to the power 9 for 1 by 4 pi epsilon 0. Both QA and QD, they are equal to 16 microcoulombs, so it will be 16 into 10 to the power minus 6 whole square. RAD is 0.2 whole square. That value, if we calculate, it is coming 9 into 10 minus 16. It is coming around 57.6 Newton. Same will be the value of FC. FC will also be equal to same because all the values are same, 1 by 4 pi epsilon 0 QA QC. Okay, FC will be QDQC QD because we have picked QDQC by RCD whole square. Same 9 into 10 to the power 9. QD and QC, they are equal, 16 into 10 to the power minus 6 whole square. RCD is 0.2 whole square. Everything is the same, 57.6 Newton. Okay, FA and FC, they are the same, but they are different directions. They are acting along different directions. FA is acting along the horizontal direction towards the positive x-axis. FC is acting in the vertical direction towards the positive y-axis. FB will be equal to, let us determine it here, FB will be equal to 1 by 4 pi epsilon 0 QBQD by RBD whole square. 9 into 10 to the power 9 into 16 into 10 to the power minus 6 whole square. RBD is this much. Okay, this is distance RBD, 0.2 whole square plus 0.2 whole square root over. That whole square. So this value, it is coming around 28.8 Newton. So please be careful with these calculations. There are a lot of calculations. It is very easy to make mistakes because it gets tiring, to put the same values and all that. So please be very careful during these calculations. One small mistake and the whole solution will be wrong. So we have got FA as 57.6 Newton. Okay, FA 57.6 Newton. FC as also 57.6 Newton. Angle between them is 90 degree. This will be the resultant of FA and FC. See here, FC and FA. The resultant will be this. Okay, so this will be simply equal to FA square plus FC square plus 2 FA FC cos 90 degree because the angle between them is 90 degree root over. That will be the resultant of FRAC. This will be equal to 0, so it will be simply equal to FA square plus FC square. So that will be equal to 57.6 root 2 Newton. Now if you see FRAC, the resultant of FA and FC, and the direction of FB vector, okay, they are the same. FB vector, it is also along the same direction. FB vector is also in the same direction as FRAC, okay, point D it is. So the net force acting on the charge placed at D is FRAC plus FB, okay, magnitude wise. That will be equal to 57.6 root 2 Newton plus this FB we calculated as 28.8 Newton. So this is coming around 57.6 root 2. It is coming around 81.5 plus 28.8 Newton, that is equal to, it is coming around 110.3 Newton. So the net force acting because of all the other charges placed at the remaining three corners at D, point D, is equal to 110.3 Newton. Okay, so it was given that we have to pick any one corner of the square and find the net force, the total force acting because of the other charges. So we picked corner D. We found out the forces of interaction between this charge placed at D and all the other corners, between A and D, B and D, C and D. These were the forces and their respective directions. Then we found the resultant of FA and FC. It was in the same direction as FB. So we just simply added them together and we got the result. Okay.